2. That is great. Okay, let's get on to number 2. 2 on the same page, you're constructing a pen for goats, pigs, cows. In order to minimize construction costs, the pen is built so that each pen shares at least one fence with another pen. You would like to maximize the area with only 1,000 feet of fence. See the diagram on the right. Write in the equation that models the area of the pen in terms of x, the side of the pen. Okay, well, let's go ahead and start putting variables into this diagram. So let's get our diagram here. Get that, we got that. And let's look for all of the lengths that are measure x. This is number 2. Yeah, I wrote 3 by mistake. Sorry. All right, so which lengths are x? Vertical or horizontal? Vertical. Okay, we're going to make that x. We're going to make that x. We're going to make that x. How many x's do we have? We have 4 x's. Good. How about this right here? What length is that? Yeah, we don't actually know. So we'll call that y. This length is y. Okay, how many y's do I have? I got 2 of them. If I put all the x's and all the y's together, they will add up to. They'll add up to 1,000. Good. So you got the 4 x's plus the 2 y's. All of that added up together is 1,000. F of x equals area. And based on my diagram, the area is really easy, right? It's just x times y. So why is that not the answer? Okay. This should be in terms of x. Is this equation in terms of x? No, it is not. So this models the area of the pen in terms of x. Okay, cool. So I got to get rid of that y. Any idea how I would solve for y? Good. Divide everything by 2, subtract over 2x now. So it's 500 minus 2x. That's my equation for y. That's what we're going to put here. 500 minus 2x. You want to distribute? $500x minus 2x squared. Okay. Okay, so now we're going to maximize the area, right? Maximize. Okay, so the first question is, I need to know what's the smallest that x could be. Should be 0, yeah. Okay, so now the other one is, what's the biggest that x could be? Let's look at our diagram. We have 4 x's, right?
Y can't be 0.
Y could also be 1/2 or 1/4 or 1/8, but it will approach 0 to maximize x. So as y approaches 0, what does x approach? X approaches 250. So we know that x must live, it must be some number between 0 and 250. Now that I have that, I should be able to use a candidate test here. Yeah, we haven't done that yet. You're right. Let's figure out our critical number. What was my equation of f? 500x squared, f prime of x. dx, but yeah. Okay, now that I know that we got f of x equals that, do we have any critical numbers? Which one's that? Perfect. I have a critical number, I have a domain for x, a finite domain for x. I should be able to use a candidate test. So let's get our candidate test assembled. What was that? Candidate test. We're going to need a column of x's and a column for the area. Good. What are my candidates? $125, that's a good one. Any other candidates we need to test? 0. Need to test 0. Any other candidates we need to test? 250. Any other candidates we need to test? No. Okay. What happens if I plug in 125 into my area formula? By the way, what was the area formula? $500x. That's great. Okay, let's substitute 125, give me an area. $250? Is that right? Okay, plugging in 0 should be easy, right? Plugging in 250. That should be 0 as well. So it appears as though I found my maximum area. So maximum area.
So would it always get critical number or no?
as opposed to,
Just like 0 or the other numbers.
if it was always a critical number, I wouldn't have you test the endpoints. What is that? Square feet? Yeah, square feet. When x equals 125 feet. That's great. Okay, so we have done numbers 2 and 3. We're going to do 4 after school. We should probably do, no, we're going to have to do 1 after school. Do you want to see 1 or do you want to see a different problem?